Most off-grid owners assume their battery bank runs flat because they use too much electricity. Yet in thousands of real systems, the biggest drain is sitting there in plain sight, the inverter. What the industry rarely emphasizes is that selling larger batteries and higher capacity inverters is far more profitable than showing people how to stop wasting the energy they already have. That hidden loss keeps pulling power every hour of the day. Not while you're running heavy tools or brewing coffee, but while absolutely nothing useful is happening. Once you understand why one simple, inexpensive change can eliminate much of that waste in the right setup, you'll never judge an off-grid system the same way again. Spend enough time around experienced off-grid builders, RV owners, cabin operators, or solar enthusiasts, and you'll hear endless conversations about battery chemistry, panel sizing, inverter wattage, and charge controllers. Those topics matter, yet seasoned users eventually discover something beginners often miss. Because efficiency isn't only about the electricity you consume, it's also about the electricity quietly consuming your battery in return. Every off-grid system has invisible losses. Some are unavoidable, others come from design choices, and one of the biggest begins the moment the inverter is switched on. Most people picture a simple scenario. No appliances are running, nothing is plugged in, and the battery should be sitting almost untouched. The hidden catch is that an inverter doesn't work that way because it isn't just a switch. It's an active electronic device that keeps powering itself even when every connected appliance is idle. Its control circuits remain active. Its monitoring systems never stop watching. Its oscillators continue operating. And depending on the design, even the cooling system can consume power. None of that stops simply because your television is off, your refrigerator isn't cycling, or your laptop isn't charging. The inverter is still working, even though it appears to be doing absolutely nothing. Manufacturers describe this behavior using several different terms, including idle consumption, no-load draw, standby power, and quiescent current. The wording changes from one brand to another, but the meaning never does. Your battery pays a constant energy tax simply because the inverter is left on. Experienced off-grid users recognize that tax almost immediately because it never takes a break. It doesn't stop overnight, it doesn't care that you're away from the cabin, it doesn't care that every light inside the RV has been switched off, and if the inverter stays on for 24 hours, the idle draw keeps running for the same 24 hours. Unlike a dramatic equipment failure, there isn't a flashing warning light telling you what's happening. Instead, you wake up to a battery bank that seems to discharge faster than expected, which meant many owners started blaming the wrong components. The batteries get blamed, the solar panels get blamed, cloudy weather gets blamed, and some people even convince themselves they simply need a larger battery bank. None of those expensive fixes solve the real problem because the hidden load has been quietly draining energy the entire time. Long-time off-grid users know this frustration well because battery capacity calculations often focus on appliances while completely overlooking inverter self-consumption. Everything looks perfect on paper, yet real-world performance never quite matches the calculations, and that is exactly when the math starts falling apart. Smaller systems expose the problem even faster. A compact battery bank has much less stored energy to waste, so even a modest amount of idle consumption becomes a much larger percentage of your available capacity. That's where this stops being theory and becomes simple math. Imagine an inverter with a 20-watt idle draw. Most people hear 20 watts and immediately dismiss it because the number sounds insignificant, yet electricity doesn't care whether a number feels small. It only cares how long that number continues. 20 watts running non-stop for 24 hours adds up to roughly 480 watt-hours every single day. In a 12-volt battery system, that's about 40 amp-hours consumed without powering one useful appliance. Pause and think about what that really means. Your battery isn't running power tools, it isn't heating food in a microwave, and it isn't charging your electronics. All that energy is being spent for one purpose: keeping the inverter awake. Once those numbers become real, the conversation changes. Instead of asking how to buy a bigger battery, experienced owners begin asking why they're paying for electricity that accomplishes absolutely nothing. That's where one of the simplest improvements in many off-grid systems begins. It doesn't start with another battery, another solar panel, or another expensive hardware upgrade. It starts by eliminating unnecessary waste. The interesting part is that one inexpensive modification or even a feature already built into many quality inverters can make a surprisingly large difference depending on how your system is actually used. Before looking at those solutions, there's another misunderstanding that quietly costs people even more stored energy. Many buyers assume every inverter behaves the same. They don't. That single assumption leads straight into another expensive mistake. Walk through almost any off-grid discussion, and you'll hear people comparing inverter wattage the same way car enthusiasts compare horsepower. Bigger sounds better. 3000 watts must be a smarter investment than 1000 watts, and more capability feels like the obvious choice. The real problem is that idle power doesn't always work in your favor. Larger inverters generally consume more energy while they're sitting idle, which meant buying an oversized inverter for a very light daily workload can quietly increase standby losses every single day. Picture a high-capacity inverter spending most of its life powering only a handful of low-demand devices. On paper, you've future-proofed the system, but in reality, your battery could be paying a much larger idle penalty simply because the inverter spends nearly all of its time waiting for work that rarely arrives. That's why experienced off-grid builders don't stop with one question. They certainly ask whether an inverter can handle the maximum load, but they also want to know what that inverter costs while it's doing absolutely nothing. Those are two completely different ways of thinking. One is focused on capability. The other is focused on efficiency. Efficiency is what ultimately decides how long your stored energy lasts. That's when many off-grid owners realize the biggest upgrade isn't adding capacity at all. It's recovering the capacity they were unknowingly losing every single day. Now let's talk about the so-called $10 modification. First, there's an important reality check. No universally recognized hardware modification costs exactly $10 and magically doubles battery life in every off-grid system. Anyone presenting that as an engineering fact is selling a headline, not the whole story. What does exist are several inexpensive methods that dramatically reduce unnecessary inverter losses when they're used in the right situations. The simplest solution is almost too obvious. Turn the inverter off when you don't need it. You can do that manually, or you can use a low-cost external remote switch that commonly sells in roughly the $5 to $15 range. The principle couldn't be more straightforward. Instead of leaving the inverter energized 24 hours a day, you only switch it on when AC power is actually needed. The moment the inverter is turned off, its idle consumption disappears with it. No standby drain, no internal electronics quietly consuming battery power, no invisible energy tax. Simple solutions are often ignored because they don't feel exciting. People naturally chase complicated upgrades because complicated sounds valuable, yet physics doesn't reward complexity. It rewards efficiency. Manual switching isn't practical for every setup because some systems require continuous AC availability, while others have equipment that must remain powered around the clock. Manufacturers recognized that problem years ago, which is exactly why many higher quality inverters include features called ECO mode, search mode, or power saving mode. The idea behind these modes is surprisingly clever. Rather than generating AC power continuously, whether anything is using it or not, the inverter periodically checks for a meaningful electrical load. If nothing significant is detected, it dramatically reduces its own power consumption while waiting, and the instant a sufficient load appears, full operation resumes automatically. Instead of wasting energy producing AC power 24 hours a day, the inverter spends much of its time in an extremely low consumption state. That's not clever marketing language. It's an engineering solution built to solve a real efficiency problem. The improvement can be substantial. One example summarized from Victron Energy Information shows a normal idle consumption of around 20 watts, dropping to roughly 8 watts when eco mode is enabled. Some newer inverter designs go even further. Certain models are summarized with normal idle figures around 8 to 12 watts, while eco operation can reduce that number to approximately 0.6 to 1.5 watts. Notice what didn't change. The battery didn't suddenly become larger. The solar panels didn't become more efficient. The inverter simply stopped wasting so much energy while waiting for something to power. That difference completely changes how experienced off-grid owners evaluate equipment. Instead of focusing only on how efficiently an inverter converts DC into AC under heavy loads, they pay close attention to how efficiently it behaves when almost nothing is happening, because real life isn't continuous maximum output. Real life includes quiet mornings, long evenings, hours away from camp, and days when only a few small devices need electricity. Those are the moments when standby losses quietly pile up hour after hour until they become impossible to ignore. Another inexpensive solution shows up frequently in DIY off-grid systems. Rather than relying completely on manual operation, many owners install low-cost timer relays, DC relays, or smart switching devices. These components typically cost somewhere around $8 to $15, and they can automatically disconnect the inverter during the hours when AC power isn't expected to be needed. The goal isn't adding complexity for the sake of technology. The goal is automation. Instead of depending on memory, the system handles repetitive energy-saving decisions by itself, which ultimately prevents countless hours of unnecessary standby operation over the life of the installation. That said, responsible engineering requires one important clarification. Reducing idle consumption is not the same as creating free energy. You're not increasing the size of your battery bank. You're protecting more of the capacity that was already there. That distinction separates realistic expectations from internet hype. The phrase "double your battery life" makes an irresistible headline, but engineering has always depended on context. Whether your runtime improves a little or improves dramatically comes down to 4 factors that consistently appear throughout the research: the size of your battery bank, the inverter's idle draw, the loads you're actually powering, and the number of hours the inverter spends sitting there doing absolutely nothing useful. Imagine a battery with roughly 1200 watt-hours of usable energy. Now picture an inverter quietly consuming around 20 watts every hour simply because it has been left on. After 24 hours, approximately 480 watt-hours have disappeared before you've powered a meaningful appliance. Remove most of that unnecessary loss, and suddenly much more of your stored energy is available for the things you actually want to run. In systems with very light overnight loads, the improvement can feel dramatic. In systems carrying heavier loads, the gain may be smaller, yet the underlying principle never changes. Stop wasting energy and you keep more energy. It's a simple equation, but it's surprisingly easy to overlook. There is another lesson hidden inside this entire discussion. The off-grid community naturally gets excited about major purchases. New batteries, new solar panels, and higher capacity inverters attract the attention because they're easy to see. Yet some of the smartest improvements never involve adding more hardware at all. They come from removing unnecessary losses. That's a completely different philosophy. It's the difference between making the bucket bigger and sealing the hole in the bottom. That same philosophy explains why manufacturers have spent the past decade steadily reducing standby consumption. Higher efficiency pure sine wave inverters became increasingly common throughout the 2010s, with much greater attention given to minimizing idle losses. Later, eco mode and search mode became standard features on many premium off-grid inverters, and the push toward lower standby consumption hasn't slowed down. Modern portable power stations are now competing on idle efficiency as well. One recent example highlighted the Anker Solix S2000 with an idle draw of around 6 watts, while noting that many competing products consume around 30 watts. That difference exists even when you're not actively using the available AC power. Manufacturers understand something consumers are finally beginning to recognize. Runtime isn't determined only by battery capacity. It's also determined by everything quietly consuming that capacity in the background. Of course, no engineering solution is perfect. Surge mode isn't the right answer for every application, because some extremely low power devices may never draw enough current to wake the inverter. Certain appliances with intermittent operating cycles can also behave unpredictably if the inverter repeatedly enters and exits its power-saving state. Like every engineering decision, it's a trade-off. Understanding those trade-offs is what separates informed system design from marketing promises. Perhaps that's the biggest takeaway from this entire conversation. The common enemy isn't any single manufacturer. It's the habit of judging equipment by the biggest number printed on the box while ignoring the smaller numbers that determine day-to-day performance. Peak wattage grabs attention. Idle consumption determines efficiency. One sells products, the other determines whether your battery is still full when you wake up the next morning. Experienced off-grid owners eventually stop chasing impressive specifications simply because they look good on paper. Instead, they begin asking quieter questions that reveal where the real efficiency is hiding. How much power disappears when nothing is happening? How efficiently does this equipment behave during the other 23 hours of the day? Where are the invisible losses hiding? Those questions rarely appear in advertisements, yet they're often the ones that save the most energy over time. As off-grid technology continues evolving, the systems that stand out won't necessarily be the ones with the biggest batteries or the highest inverter ratings. They'll be the systems engineered to waste the least, because generating electricity is only half the battle. Keeping that electricity from quietly slipping away is where real efficiency begins.